But let me first tell you that what is neural network. Let's discuss a bit about the neural network. That what is basically neural network? What is the phenomena of the neural network in deep learning? Let me first pick a biological neural network. This is the biological neural network in the nervous systems of the brain. These are the dendrites. This is my cell body. This is axon. Here is the output terminals. So I can say that it is brain neural network. It is the biological neural network. So compared to this biological neural network, I have an artificial neural network, which is this. It is artificial neural network. Now let's do some comparison between the artificial neural network and the biological neural network. On the left side, as I said, it is the brain neural network in the nervous system. So it is a biological neural network where this center is my cell body, where this is my cell body, this is my cell body. These terminals are the dendrites which receive inputs. It receives input and then the cell bodies decide to pass the information through the axon to the output terminals here. With the help of these output terminals, we get output. Exactly the same phenomena applies on the artificial neural network on the right side. Look, XM1, XM2, XM3, XM4 is like my dendrites. These are the terminals which receive informations from the outside with a kind of weight. W sub 1, W sub 2, W sub 3, W sub 4. These are the weights. So what are weights? These are the random values which have the product with the input. So time by time we update these random values to get the accurate output. But don't worry, we are going to go in depth in upcoming lecture that what is weight, why we need weight, what is the importance of the weight. So when it receives the information here, it takes the product with a weight like x sub 1 times w sub 1 and then it comes here. Here the summation takes place like x sub 1 times w sub 1 plus x sub 2 times w sub 2 plus x sub 3 times w sub 3 plus x sub 4 times w sub 4. So it is the summation process here. It is like exactly this cell body. It is my cell body, suppose, where summation takes place and then here activation function applies. Now the job of the activation function is to decide whether the neuron should be activated or not, or the neuron should be fired or not. It is the controller. It is the controller here, like the cell body does. Here the cell body decides whether I need to pass these informations to the terminals, to the output terminals or not. It is the controller. It is the controller here. So the same job has been taken by the activation functions in the artificial neural network. So if the neuron is fired, then it goes to the output terminals here, to the output terminals to get the final output. So almost everything is mutual between brain neural network and artificial neural network. I repeat this again. This is the biological neural network, which is the brain neural network in nervous system in our brain. This is my cell body. These are the dendrites which receive the information from outside. So once the information enters to the cell body is like a controller. It decides that whether the information should be passed to the output terminals or not. So when it decides that I should pass the information to the output terminals, the information goes with this path to the output terminals. So the same thing happens here. X sub 1, X sub 2, X sub 3, X sub 4 are the inputs which receive information from the outside. So once it receives the information, it takes the product with a weight, which are the random values, and then summation takes place here. It is like the cell body in the brain neural network. So where summation takes place and then the activation functions does the job of the controller. It decides that whether the neuron should be activated, fired or not. So if it decides that I should pass it ahead, it goes to the output terminal here. Here we get the output. It is my artificial neural network. This is my biological neural network. So there was a simple comparison of the neural networks. Let me show you a simple neural network here. This is a simple neural network where each and every single cell has been linked with another next cell. This is my input layer, this is hidden layer, and this is the output layer. It is a basic neural network. This is the graphical perspective of the neural network. It shows that how neural network looks like, where the first layer is the input layer, the second layer will be the hidden layer, the third layer will be the output layer. But don't forget, each and every single cell is connected to the next cells of the hidden layer and also to the next cells of the output layer. For example, if I have one cell in the output layer, this is a single cell in the output layer, which means that I have only one input. And then in the hidden layer, if I have three cells, these cells must be connected with all the three neurons here, to this, and to this. You cannot skip anyone. You have to link this cell to all the three neurons in the hidden layer. And then further, all the three neurons must be connected to the output, to the cells in the output layer. 1, 2, 3. You cannot skip it. So in the neural network, all the cells are connected with each other. There might be two neurons, which means two inputs, three neurons, three inputs. 5 neurons in hidden layer, can be 10, can be 4, can be 5. Similarly here, there might be two neurons, which means two outputs, 3 neurons, 3 outputs. So it depends on the neural network. What kind of neural network? The more you have neurons in the neural network, the more it will be complicated.